Hello, this is Thursday, September 29th, and here is our lesson today. We are on day 5, the discriminant. So today I am away at Casa Golf, but you can always watch this video, which is right here. So you've already clicked on the video and you're watching it right now. So looking at the discriminant, we are going to find the discriminant, which is actually a part of something that we've already seen. So we have the general quadratic equation ax squared plus bx plus c equals 0, where a, b, and c are, what's that? What's this mean? Elements of the real. So that means a, b, and c are all real numbers, and a can't be 0. Why can't a be 0? Well, if you guess that if a is equal to 0, we don't have a quadratic, we would therefore have a line, you'd be correct. And we have the quadratic formula is given by, you should know this already, x equals negative b plus or minus the square root of b squared subtract 4ac all over 2a. So the equal sign is not under 2a, it's everything is under 2a, and that our square root sign is all underneath this thing right here, which is really important, which is all about today. The formula here can be used to determine the values of the roots of a quadratic equation, as well as their nature. So their nature just means let us know kind of what it looks like without telling us what it looks like. Sorry about that. The nature of the roots refers to the type and number of roots for an equation and not their value. So it's just telling us how many roots are there. Are we going to have something that looks like it's going through the x-axis twice? So 2 distinct real roots. Are we going to have one place, so 2 equal real roots, or no places, so 2 complex conjugate roots? Let's figure that out. Well, we have this part of the quadratic formula, the one that's highlighted, is going to help us figure that out. This is b squared subtract 4ac. And that's what we call the discriminant. So the discriminant, when it's positive, so when we get something that's positive underneath the square root sign, so it's bigger than 0, it's positive, there are going to be 2 distinct real roots. So that would look something like this, where it would be crossing the x-axis at 2 different places. When the discriminant is equal to 0, so we have b squared subtract 4ac is equal to 0, so whatever we get underneath the square root sign is 0, then that means that there are 2 equal real roots where our parabola is just touching the x-axis. It looks like one place, but it's actually 2 places. There's 2 real roots, 2 equal real roots there. And then when the discriminant is negative, so what's underneath the square root sign is negative. We've dealt with things like that before. Negative square root with a negative value. So this would be less than 0. There are 2 complex conjugate roots. So that means that our graph is going to be something like this. It could be up in the sky or down underneath. If it's maximum or minimum, doesn't really matter, but it's not touching the x-axis. All right, so let's check this out. So here it says examine the discriminant to determine the nature of the roots. So we're not looking for the roots. We don't care what the roots are. We just want to know what is it going to look like for the following quadratic functions. All right, so we have this one right here. We have our a, our b, and our c. Now we don't have to go and set up the quadratic formula because we're just looking for the nature of the roots. So that means we're just going to set up b squared subtract 4ac. See what's underneath that square root sign. That's going to let us know what's going on. All right, so let's put in b for b, a for a, and c for c. Okay, so we've got 4 squared subtract 4 times 3 times 5. It looks like we have like 16 over here and a bigger number over here that's being subtracted. Could you kind of guess what you're going to get? All right, so we get 16, and then this is going to give us 4 times 3 is 12, times 5 is 60, so we're going to subtract 60. So here we're definitely going to get a negative value. Negative 44 is less than 0, so therefore there are going to be 2 complex conjugate roots. All right, so that means if we go and graph this, it's going to look like something that is not touching the x-axis. Right, it's going to be up in the sky or down low, but it's definitely not touching the x-axis. Probably like something, it could touch the y-axis, that's totally fine if it has a y-intercept, but it's definitely not touching the x-axis, something like that. All right, let's go ahead and try this one. So here we have A, B, C. So again, we're going to fill in b squared subtract 4ac. That's our discriminant. It's going to let us know the nature of the roots. Okay, so b is negative 4, and this is going to be squared in brackets 4 times 1. Well, this is 16 minus 16, which is 0. So therefore, there are 2 equal real roots. All right, so that's going to be where it touches at one specific place. So it could look something like this, where it's just touching the x-axis at one place, but there's actually 2 roots there. They're both equal. So they're kind of like on top of each other. And then our last one here, again, we have A, B, C, where b is negative 4 squared subtract 4 times 2 times negative 3. See that we're going to get that positive there, so we should get a big value here. So negative 4 squared is 16, and then we have that double negative, so that will be a positive. 4 times 2 is 8 times 3 is 24, giving us a total of 40. And 40 is bigger than 0, meaning that therefore there are 2 equal real roots, or 2 distinct real roots. Meaning that our parabola is going to cross through at 2 different places. Let's go check them out. Let's go see what they actually look like. So here we are. Here we have the graph of the first one, and we can see that it is not crossing the x-axis. So they are complex conjugate roots, or imaginary numbers. Here we have, it's touching just at one place, but it's actually 2 roots that are identical here. That's our second one. And our third one, we can see that we have 2 distinct real roots. It's crossing at 2 places. Right, if you have any questions, let me know, and I will see you tomorrow in class. Bye, guys.